Particular welcome to WPA members. This is very much a double-headed event, and all the stronger for it. So we really value this partnership with the Timber Trade Federation. So I am now going to share my screen with you. And basically what I'm going to talk to you about this morning is a combination of the dynamics of the supply chain for flame retardant treated wood products, but also to be good to take this opportunity this morning to review the regulatory situation, both the existing and consultations that are current at the moment. So I'll come back to that as we go through. One of the services that the WPA runs is a specifier helpline, if you like, and we handle a whole range of queries on the correct specification use of treated wood, modified wood products. When it comes to flame retardant treated wood, we categorize them all, and there's a category that comes up head and shoulders above anything else, and that's terminology. Any of you have heard me speak on this before. You may have heard this before. I'm not going to apologize for doing it again because we can't repeat this too often. It is a source of such confusion, both within the specifier area and within the supply chain. So I'm not going to make it too complicated, but there are some basic terms that we absolutely must understand if we're operating in this market. And to help us do that, I'm going to start by looking at the process of development of a fire. And hopefully, that's it. There are four main stages in the development of a fire. If you can imagine, if you're sitting in a room at the moment, that there is a source of ignition in the corner of that room, what influences the development of that fire? Firstly, it's the ignitability of the materials, the substrate that the flames are touching. How readily will a material ignite and catch fire? And then does the growth, the spread of flame, once ignited, how quickly will the flame spread across the surface of that material? And associated with those two, we also need to understand the heat release. Some materials release more heat than others, and obviously the more that's released, the more it contributes to the growth of the fire. Smoke production and the production of flaming droplets. Are the droplets that are actually on fire spitting out from that material and igniting other surfaces? And all of these factors are elements of a material's reaction to fire properties. So during this early stage in the development of a fire, those reaction to fire properties are our primary concern. You get to the point where all of the surfaces within the room are alight, and then we get over to what's called flashover point, where basically the room is just a ball of flame, and the temperatures rise very quickly, as you can see from the graph. That then continues as the fuel, the materials in the fire are consumed, and then eventually decays away. If you have flame retardant treated substrates in the wall, floor, ceiling, whatever it may be, then you can see from this graph the effect that has. It basically depresses the rate of the development. So it would slow down the ignition, it would slow down the spread of flame, it would reduce the heat release, and so on. And what that does is to really push back the point at which flashover is reached, and that provides time. It provides time for people to escape from a building, for the fire to be put out, and in addition to that, in certain circumstances, it will actually lead to the fire putting itself out, effectively running out of fuel early. So that clearly makes an enormous difference. But what we're looking at there is these early stages of the development of fire. So just to sum up on that, reaction to fire properties are the ignitability, spread of flame, heat release, and then flaming droplets and smoke. And all of those factors are elements of a reaction to fire. And we can measure those, and we can test them, and we can affect them using treatments, and we can actually certify a material, give it a fire classification report to explain what its reaction to fire properties are. And the photo in the right-hand side of this slide is what we sometimes call an SBI test, and single burning item test, and it's basically doing what I explained at the beginning. It's like mimicking the corner of a room, source of combustion, perhaps a waste paper basket or something, and then how do the substrates react to that fire. And when you do those tests and those measurements and you put the data together, what you get is a classification. And these days we've moved away from British standards to Euroclass, and we have Class A through to Class F, Class A being the best and F the worst. And you'll notice Class D, we've got in brackets there, that's the standard CE mark classification without further testing for wood products. So if you don't test a wood product, it will by default be classified as Euroclass D. Using a flame retardant treatment, we can enhance that to either Class C or Class B. And I'll talk a little about building regulations shortly, so you can see where those classifications might come into play. There is a significant improvement in performance from Class D to Class B. But one of the things that's been very topical recently, and again, when we talk about building regulations, you can see the impact it has, is that for certain buildings, particularly high-rise buildings, building regulations are now insisting on Class A. And Class A is either limited or non-combustible. And sadly, it is not technically possible to enhance a wood-based or any organic-based substrate, for that matter, to Class A. And so that has an impact on the use of wood products. We'll come back to that in a moment. But this term combustible is much misused and misunderstood. Theoretically, technically speaking, Euroclass B materials are limited combustibility, but they are combustible. But there's a massive amount of difference between that and the Euroclass E or F material. And sadly, the market, the media tend to see these things in black and white terms rather than a spectrum of performance. So you can specify Euroclass B, C, whatever your particular application requires, but on top of that, there is a secondary classification you need to be aware of for flame retardant treatments, and they relate to the service class in which the component is being used. So service classes are defined in BSEN 1995, and in another EN 16755, this one looks at the durability of the flame retardant treatment. In other words, if you put the treated wood or treated sheet material into a particular service class environment in terms of exposure to leaching, weather, and so on, how long does it last? And we have three classifications of durability of a flame retardant. Interior 1, which is only for dry interior applications. Interior 2, where again it's interior or we call them semi-protected. It could include cladding that is coated and maintained. So the treatment is not directly exposed to leaching environment, but they're suitable for humid environments. And then an exterior classification, which is suitable, for example, for cladding without a coating for an extended period of time. So that classification of durability is also important, and you need to specify both the Euroclass and the durability class to have a full product specification. So how can you enhance the flame reaction to fire performance of a wood-based product to Euroclass B or C? Well, there are three methods. The most traditional is the vacuum pressure impregnation of solid wood or plywood. You wouldn't impregnate OSB or similar materials, it would structurally damage the material. And that's a well-established technology. The application plant are very light preservative treatment plants. The second option is to incorporate the flame retardant in the manufacture of a wood-based panel. We've had FR-MDF on the market for some years. We've also had FR-OSB on the market now for some time, and increasingly we're seeing plywood products offered with the flame retardant built in, either to the glue line or diffused through the veneers, or both. And we'll come back to a little later the implication for CE marking and construction products rates of these different types. But suffice it to say, 1 and 2 are well-established technologies that are trustworthy and good track records. Surface application certainly can be effective, but the caveat there is it really needs to be done in a factory setting. And the reason we say that is that the effectiveness of a formulation depends almost entirely on its correct application. If you test the product at a particular loading, then when you apply it for a project, it has to be applied at that loading to get the performance rate. And it's very difficult to ensure that is done properly on site. And so WPA, when we consider our approval scheme, which I'll mention later, on products, we'll only consider coatings applied in under factory production controls. Now, there's another term that I haven't mentioned yet, and that's fire resistance. Now, if we think back to that graph I showed at the very beginning, we were talking about reaction to fire properties being the critical factors during the development of fire and the growth stage of a fire. Once you get to flashover point, the reaction to fire properties of the material become almost irrelevant. It's too late. And then you have to think about containment of that fire. And that brings in a different set of considerations, a different set of test methods. Once you get to flashover, all the combustible materials are assumed to be burning. Now, you achieve containment through the performance of the building structures and design elements around the room, such as walls, ceilings, floors, doors. So not by the performance of individual materials or substrates, but by building elements. And that could comprise several materials in combination, facing, frame, insulation, backing face, etc. And a fire door is a really good example of that. And it's the resistance to fire performance of these composite elements that is critical. And again, that can be measured. So containment, building structures and design elements, gives a fire resistance performance. And as I say, that can be measured, and it's normally expressed in minutes of resistance to fire. So we talk about a fire door being 30 or 60-minute fire resistant. Now, the reaction to fire and fire resistance classifications are really what I was referring to at the very beginning when I said people get in a muddle about specifications. We see, well, we've had a number of contractors on to our helpline saying, I've got this specification, it doesn't make sense. And when you look at it, it's because the specifier has completely mixed up the concepts of resistance to fire and reaction to fire. They are completely different things. If you're wanting to revise this and make sure you've got a definitive explanation, can I recommend our guidance note on the subject, which is available either through WPA or TTF website. It's guidance note number 1. So this is not just our experience, it's a widespread issue that specifiers and contractors on the whole don't understand this terminology. This was some research done by a WPA member. It's a couple of years old now. They tell me that they've continued to build up this database, but the results look essentially the same. So when you ask what is reaction to fire or fire resistance, the correct answer is given by between a third and 40-something% of specifiers, which is a very clear explanation of why this is a regular problem. And I think as the supply chain, we have part of the solution in our hands, that we can help specifiers to get this right, but we need to understand it and use it correctly ourselves. So moving on from terminology, let's have a look at building regulations. And we've probably had more building regulation changes in this particular area in the last couple of years than we've seen in the last 10, I should think. Obviously driven by the reactions to the Grenfell Tower tragedy, where many things did go wrong. So at the beginning of 2019, building regulations were quite substantially reviewed. And for cladding and, I'll explain in a moment, external wall structural timbers, this had a significant impact. So approved document B, section B4, now requires that combustible materials not be used on any external surfaces or indeed within the external wall of what they define as relevant buildings, and I'll explain a little bit what those are, where the building is at least 18 meters above ground level. Relevant buildings include residential or buildings containing some sort of institution. Now that would include hospitals, care homes, sheltered housing, dormitories and boarding schools, student accommodation, and some schools. Now, as I say, that affects cladding, but because the wording of Regulation 7 within the building regs says work should be carried out so that materials that become part of an external wall or specified attachment are of European classification A2, that's non-combustible. It also affects the structural timbers within the external wall. And so this has had a significant impact. I would say the impact on the cladding market, direct impact, has been minimal because there aren't that many buildings over 18 meters with timber cladding on it. But it has had an impact on the CLT market, where high-rise buildings are obviously a key market. For those buildings that are not classed as relevant buildings, so everything else. Below 18 meters, the requirements of building regs have not really changed. So faces of the building less than a meter from the boundary, Euroclass B, and then for access, for public access buildings, Euroclass C is required below, or further away rather than a meter from the boundary. And then above 18 meters, same thing, closer than a meter from the boundary, Euroclass B, and then the rest of the facing would normally be Euroclass C. So that hasn't changed, but for what they're classing as the relevant buildings, then obviously it has been a major change. Scotland's been slightly different, as it often is, and for them, essentially, when you distill it down, it's a very similar change to their building regulations, except they have taken the threshold as 11 rather than 18 meters. And we'll see that that's now become a talking point for the rest of the UK as well. I'll come back to that shortly. So yes, step 2 of this consultation and review of building regulations. Essentially, the consultation that's ongoing at the moment, and they've extended the closing date for responses to the 25th of May, you've got 4 days left if you haven't done it yet, is to further tighten these controls and reduce the threshold to 11 meters. And as I say, this would apply to both cladding and external wall structures. Now, clearly, this continues to be bad news for the CLT sector. But once you get down to 11 meters, you're starting to bite into the upper end of what we might view in the trade as traditional timber frame buildings. And that's a real concern. And if it was to go any lower, that would have serious consequences. Our view as an industry is this simplistic tick box approach to the consultation is at variance with the measures that Dame Judith Hackett was calling for in her review, which we'll come back to a little later, which were more about changing the culture. And I think, to be quite honest, a lot of this is driven by politics rather than technical considerations. But it's a serious issue that we need to respond to. So both the TTF and WPA are part of the Confederation of Timber Industries, and together we have developed a response, and I know for a fact that TTF and WPA have responded, and several of our members have. And Nick will be running a short poll at the end just to check whether you have responded, whether you intend to in the few days that are left. But I just want to give you the highlights of our response. The main points are freely available. The government doesn't like it if everybody sends in exactly the same wording, so you'll have to do your own variation on the themes that we're using, but feel free to use the CTI position as a starting point. Height is only one factor that influences fire performance. That's an obvious thing to say, but that's not the approach that these regulations take. They're relying on height as the single factor to determine which materials can be used. So, because things need to be looked at in a more holistic way, we believe that an independent professional fire risk assessment that considers design, materials, location, building type has to be mandatory and has to be part of this. The irony is that this principle has actually been embodied in CDM regulations for some years, but there's no doubt about it that project managers and contractors, sadly, will look at regulations in a bit of a pigeonhole way. They said, we passed building regs, that's all we need to worry about, and they forget that there are other regulations they need to check as well to see whether they cover these things. There was a classic example last summer. Some of you may have remembered the blocks of flats in Barking, where there was serious fire, and the outside, it wasn't strictly speaking cladding, but there was a lot of timber on the front of these buildings. There was timber balconies, there was ornamental timber structures on the outside. And when you looked at a photograph of those buildings, which were less than 18 meters, I think anybody who understood the principles of fire protection would have said that timber should be flame retardant treated. But because the building was less than 18 meters, it wasn't, and the consequences were quite significant. So it needs to be more sophisticated, and simplistic bans lead to perverse outcomes. And in the case of timber, of course, it's discrimination against a much more environmentally sustainable building method, and that's a point that we've stressed time and again. So the government actually says in its consultation, after these regulations are implemented, we'll carry out some research. And we've said, wouldn't it be more logical if you did the research first? You know, that's such an obvious thing, but it really illustrates why this is politically rather than technically driven. We also have suggested that there should be more focus on the type of cladding and the fire performance of the cladding rather than just a blanket ban. And again, that brings me back to the point I made earlier, that there's a lot of misunderstanding that timber burns, whereas you can enhance its performance to make it perfectly acceptable for many of these applications. And finally, last but not least, these changes would limit the ability of the government to achieve a core part of their climate change objectives and to increase the use of sustainable timber in construction. So, complete change of topic. Take a deep breath, don't worry, I'm going to explain this diagram. It does look very complicated. Hopefully when I've finished, you'll more or less understand what it's about. It's about the supply chain for flame retardant treated wood products. On the left-hand side, you have manufacturers and suppliers. On the right-hand side, you have the end consumer contractor, and then building control and the specifier. So if we take the top left corner, here we have the manufacturer of timber products which are not enhanced with any flame retardant. They're just what they are. That might be a UK supplier, overseas supplier, whatever. And they're supplying to a UK stockist, distributor, importer, and often they'll be sold on to the end consumer without treatment, and that's straightforward. In the bottom left corner, we have a manufacturer of flame retardant enhanced timber products. So this would be, as I said earlier, something like an MDF, an OSB, or a plywood product where the flame retardant has been added during manufacture. And because they are enhancing their product during the course of manufacture, and the product is being CE marked, but the addition of a flame retardant is safety critical. So it pushes their accreditation, factory production control, authorization requirements up to a different level under the construction of products regulations, which means that the production of that product needs to be independently assessed, audited, and accredited by what is called a notified body. Notified body is a network of organizations around Europe who are competent and accredited to carry out these sorts of assessment. And in the UK, probably the two best known notified bodies are Exova, Warrington Fire, and BRE. So the manufacturer would get one of these notified bodies to assess, accredit, certify their factory production controls. That would allow the manufacturer to CE mark their product with the fire performance, produce a declaration of performance and the associated documentation, and then place that product on the market. And I use those words advisedly because under the construction products regulation, placing the product on the market is a critical thing, because the company doing that has responsibility for the correct CE marking and documentation. So if you're producing a product in the factory with an FR in it, it's all straightforward. It comes out of the factory, marked, correct documentation, onto the stockist distributor, onto the end consumer, easy. Going back to the top left, if the UK stockist distributor importer of the timber product that does not have FR enhancement wants to add that enhancement in order to satisfy an order, they need to employ a third party treatment service provider. And that treatment service provider is supplied by another class of manufacturer making the chemicals, making the flame retardant formulation. Because the stockist distributor importer in this particular relationship is placing on the market the flame retardant treated product, both that company and the treatment company need to be assessed and accredited and authorized by a notified body. Once that is done, the stockist distributor importer is then entitled to CE mark the product, or possibly change the CE mark if it had a CE mark when they first received it, and issue an enhanced declaration of performance that shows the enhanced fire performance of the product. And it is that stockist and distributor that is placing on the market the flame retardant treated material, and so they are responsible for doing that. That then moves on to the end consumer contractor and hopefully meets the specification of the specifier and the requirements of building control. I hope that's all clear. It is a complicated supply chain, the relationships are complicated, but I think that's as clear as we can put it. And again, if you want to go over that again and revise that, then there is an information sheet available from TTF or WPA with this diagram and a full explanation on it. So in the relationship between the importer owner and the treatment company in that diagram, what are the different responsibilities? So the owner of the, let's say, timber, solid timber, has to identify a treater that they know is capable of imparting the required improvement, and the fact that they may have accreditation from a notified body and maybe WPA benchmark approval as well. I'll come back to that. Will be verification of that. They need to obtain a copy of the treater's factory production control certificate. And they need to look at the treater's classification reports and ensure that the product description in those classification reports matches the material that they are sending for treatment. And this is a two-way responsibility. The treater has a responsibility in this relationship as well. Then the owner of the material must provide the service treater with a clear, unambiguous and accurate product description. This can be a minefield, particularly when it comes to plywood. I'll say a little bit more about that in a moment. and ensure that the material that's sent in for treatment actually matches the description on the classification report. Conversely, the treater has responsibilities as too, to check that the product description matches, or the product received rather, matches the description supplied by the owner and matches that on the fire test classification report. And if they're the same, or essentially the same, that's fine. If not, that should be raised with the supplier, and the material should not be treated because it's not covered by the fire test classification report. A little bit further down the supply chain, maybe you're receiving material that has been flame retardant enhanced in some way. How can you check these things? How can you establish fitness for purpose and carry out due diligence on what you're receiving? In order to establish fitness for purpose, and I know this sounds obvious, but you'd be amazed by how often it doesn't happen. You have to know what the purpose of that product is. What is the end use of that product? And what is the required reaction to fire or flame retardant durability classification? Assuming you know that, do you have a fire test classification report or evidence that the material you're being offered meets that specification? Does the documentation you have contain all the necessary information? Is it from a reputable source? There are some very dubious documents circulating in the supply chain purporting to be fire test classification reports that are not. So, and if the product on offer is much cheaper than alternatives, don't say you've got a bargain. I would, in this particular instance, because it's safety critical, ask yourself, why is this product so much cheaper? So moving into our final phase, I just want to look at the government's response to the Hackett review. And this was a document that was published in April of this year. The Hackett report was called Building a Safer Future. It got a bit of a panning in the media because it wasn't simplistic enough, I think, but most of the industry applauded the conclusions of that report, which really took a very in-depth look at some of the cultural changes needed. So the government's considered response is to establish a new national construction products regulator, and we'll be putting more stress on third-party certification schemes and basically strengthening the existing regulatory regime and bringing in reforms across the sector. The aim of those reforms is to incentivize compliance from industry, regulators and residents, and to better enable the use of enforcement powers by clarifying and focusing the regulators' powers. This will include market surveillance and a national complaints system. These such things exist in other European countries, but not here. It's very difficult to know where to go if you're unhappy about a product or paperwork or whatever it may be. But the intention is to set up a system that you can log into. To raise the profile of enforcement action with manufacturers and to develop, as I say, standards of third-party certification. These are aims that our industry should thoroughly applaud. It's what we've been asking for. I'm not sure about TTF so much, but in WPA's case, we've been lobbying for this for many years, and it's only sad that it's taken Grenfell to get us to this point. But we need to hold government to account that they deliver on these policy initiatives. Yes, a final aspect of this is competence standards, not just within industry, but also the competence of people regulating industry as well. Quick word about WPA's quality schemes. Part of the reason that we're pleased with the way that the government is going on this is that they are essentially tapping into initiatives we took many years ago to set up third-party approval schemes of formulations, treaters, and indeed distributors of flame retardant enhanced products. Much more detail on that on our website. As is all the links to our guidance produced. They're all WPA TTF dual branded documents produced together, giving the same messages right through the supply chain. And there's a whole series of them available either from WPA's website or TTF. And WPA's website also includes loads of relevant information. Much of what I've said this morning is on our website. So please do check out the wpa.org.uk.